Hey guys, good evening. So, we are going to start on a very interesting question and quite a frequently asked question in interviews, and that is topological sort in directed acyclic graphs. So, we are going to see what the problem is, and I'm sure you would find it really beneficial. So, it would be nice to have a very good interaction around this problem. Topological sort. Yeah. So we are going to discuss about topological sorting. So let's have the discussion. So let's start at around 7:34. Some of you might be interested to join in some time. So starting at 7:34. Starting at 7:34 p.m. Hi Farad. So anyway, after all these sessions, do let us know through your comments or feedback how you have felt. I hope you have visited my previous videos as well. Some of them were on Unacademy, some of them were on the CodeChef channel. So in CodeChef channel, I have actually published many recorded videos. You can have a look at them because they are quite frequently asked ones. So yeah. And about myself, I'm a six-rated coder at CodeChef, and I'm a master at Codeforces. I've been to the ACM ICPC regionals in 2019, and I've recently graduated from IIT Bhilai from Computer Science and Engineering, and I'm now moving into Google. So that's about myself. So let's wait up to 7:34, then we'll be starting. Okay, so basically, graph theory is one of the most important topics for coding contests as well as coding interviews. You're required to have really a good concept of graphs because that is where the interviewer checks whether you are comfortable with nonlinear data structures. There is graphs and linked lists is also rather a linear data structure. So mainly in graphs or in trees, the interviewer tries to understand what is your position in terms of the nonlinear data structures. Graphs, as we know, it is a nonlinear data structure. And as the term indicates, topological sorting, what we are saying is that there are many relationships among these objects and we want to sort them according to some property. So there's a very popular question or very popular domains in which this is actually exercised, but this is rather a very simple version of all those things. We'll discuss what this problem is about, and I can tell you, like in FANG companies, this has been asked quite frequently, so it would be nice to understand them. Okay, so let's begin. I'll erase this. Yeah. So, suppose you have a directed graph. Suppose you have a directed graph. Suppose you have a directed graph which looks something like this. You have two, suppose four, and then you have one, and then you have three, and then you have something like this. You have 5, and maybe you have 6, and you have something like this. Okay, so when this kind of an arrangement you have, and suppose you have a kind of story associated with it, that A to B means A should be completed before B. A precedes B. Okay, so this means that A precedes B. A should precede B. So in some sequence, if you want to arrange them where these links hold, then you need to ensure that 2 comes before 6. You need to ensure 2 comes before 1. You need to ensure 1 comes before 5. And 6 also comes before 5, something like this. And you need to arrange them in some manner. So the question is about how can we arrange them so that all these links hold true. All these links hold true. So we can say one arrangement can be something like this. We can have yeah, 2 4 1 6 3 5. 2 4 1 6 3 5. So take any pair. 4 comes before 3. We can see, yeah, 4 comes before 3. Let us see this one. 2 comes before 5. Yes, 2 comes before 5. Why? Because 2 is the ancestor of 5. Okay. So this is a proper topological sorting. What we are saying is that A should come before B. So this is a very, you can understand, very pertinent problem while scheduling is done, scheduling of courses, scheduling of classes and those things. So courses are scheduled such that if a course is a prerequisite of another course, then that course should come before. So if a course A is a prerequisite of course B, then course A should come before and course B should come later. So this is important. Suppose you have got such distinct time slots, and if you have to arrange some webinars, so that one webinar may be the predecessor of the other, so you need to sort them in such a manner that you get something like this. Okay, you get something like all the links are actually obeyed. 1 to 3 means 1 comes before 3. Now you can say, is this the only one? No, this is not the only one. You can have something like this: 2 6 4, and then you can have 1 5 3. This can also be the case. 2 6 4 1 5 3. You can have like this. This is also valid ordering. You can see from 2, like we are reaching 6, so 2 comes before 6. From 1 5, so 1 comes before 5. Over here you have 4 to 3, so 4 comes before 3, and even 6 to 5, so 6 comes before 5. All these are obeyed. So there can be multiple topological ordering possible. But let us start from the tip of this graph and let us try to understand, can we form a topological ordering so easily? What do we require to do? Let us try to understand this. When I land at this, suppose where should I start it from? I don't know which is the route. There can be multiple routes. It may be like there is some other person who cannot be reached. Suppose I started over here. I start DFS, suppose over here. I reached 1 and then I reached 5. Can I say that from here, since I cannot reach anything, this can be my order 2 1 5. I can place it something like this 2 1 5. And can I say that okay, the rest of the graph I can place after this? Because 2 will come after them? No, because the 6 will say that I must come before 5. 6 has to come before 5 somewhere, either here or here. It cannot come before 2. So here it is important that okay, we are doing simple DFS. While we are doing simple DFS, it may happen that later on we come to some such a node which will rather prescribe its own preferences. That no, I want these people to be strictly in front of me. So first time we did DFS from 2 and we continued through 1 and we said okay, these are the things, and I aligned according to that. Now I'm coming back and I'm saying from this node I want 6 to be before 5. Similarly, there can be other situations as well. Suppose something like this. You have 2, you have 3, suppose you have 1 over here. The question arises, where should you start from? All of them, like both of them, are capable of forming this. So you can say okay, maybe it's something like this 4 and it is something like 5 and 4 goes to 5, something like this. Okay. So where should you start this from? If you start from 2, luckily, because 2 seems like a root, if you start from it luckily, you can say okay, 2 4 5 and then you need 1. So when you start from 1, you can see that okay, you have already placed 5 while doing DFS like this. So simple DFS, you understand that this may not help. So what can we apply over here? What can we apply over here? A simple DFS is not helping over here. What can we apply over here? Think about it for a minute, then we'll proceed. BFS from where? So I will say, okay, suppose I do BFS from here. So I'll do 2, then I'll do 4, and then 3. These are my immediate neighbors, right? Then from 4, I'll have 5. I'll have 5 over here. Then I will say I cannot reach anywhere else. So now I'll start from 1, because 1 is unvisited till now. From 1, when I start, I see that I can reach both of them, but I have already placed 3 and 5. So either I have to pop them or I have to place 1 over here. So this ordering is wrong, right? Because 5 cannot come before 1, right? So I can say something that, okay, since since I'm not able to reach 1 from here, think about DFS only. Think about simple DFS. What are we doing? 2, 4, 5, suppose. 2, 4, 5. Then we came back and we saw 3 over here. So when we saw 3 over here, maybe I have placed 3 over here. Now, later on we are coming to this 1. When we are coming to this 1, what is one information that we know? We know that 1 has not been added to the stack till now. 1 has not been added to any data structure till now. Good evening, Sachin. So 1 has not yet been added to this particular list. So what can we say? That means 1 could not be reached from any of these nodes. इसका मतलब है कि अभी जो एलिमेंट्स प्रेजेंट है मेरे इस ग्राफ में, कहीं से भी मैं 1 तक रीच नहीं कर पाया हूँ. मैं जब अलग से 1 को लेके चालू हो गया, मैं ये समझ गया कि अच्छा यहाँ से DFS करके मुझे 5, 3, 4, 2 जो भी मिला था, वहाँ से मैं 1 रीच नहीं कर पाया था, विच मीन्स कि 1 मेरा पहले बैठ सकता है, क्योंकि 1 डज नॉट नीड टू बी आफ्टर समथिंग. अगर वो किसी के सामने बैठ सकता था, देन आई कुड हैव विजिटेड, आई वुड हैव डेफिनेटली विजिटेड दैट पर्टिकुलर नोड आफ्टर 2, 3, 4, 5. अगर ऐसा होता कि ठीक है 3 के बाद ये 1 आता, तो मुझे 3 के बाद ये मैं ज़रूर DFS करके ये विजिट कर लेता. और जब मैं देख रहा हूँ कि ठीक है मैं 1 में विजिट कर रहा हूँ, 1 अभी तक अनविजिटेड है, इसका मतलब इसके पहले मैं जो भी विजिट किया हूँ वो मुझ तक पहुँच नहीं पाए. सो मैं कह सकता हूँ इसको तुम सेफली पीछे रख सकते हो, बिकॉज सामने जो है वो कभी मेरी तरफ पॉइंट नहीं कर सकते हैं. दे डोंट हैव द एबिलिटी टू पॉइंट टुवर्ड्स मी. लेट अस ट्राई टू अंडरस्टैंड इट थ्रू दिस एग्जाम्पल. यहाँ पे हम कह लेते हैं कि ठीक है, एक ही तरीके से देखते हैं. 2, 1, 5 नीचे जब पहुँचते हैं पता चल गया कि ठीक है 5 के बाद हम कहीं तक पहुँच नहीं पा रहे. सो हम क्या कह सकते हैं कि 5 कैन बी द लास्ट एलिमेंट, क्योंकि 5 किसी का प्री रिक्विजिट नहीं है. मेक सेंस? 5 किसी का प्री रिक्विजिट, 5 इज नॉट द प्री रिक्विजिट ऑफ एनी एलिमेंट. Then what can I say? When I come back, I know 1 is coming before this. So I'll place 1 over here. या फिर मैं कह सकता हूँ कि ठीक है इसके लिए भी देख लेता हूँ और क्या क्या है. सो 1 के लिए मैंने देख लिया कि 3 है, और 3 का भी ऐसा कोई बाइंडिंग नहीं है. 3 किसी के भी पीछे नहीं आना चाहिए, पाना नहीं चाहिए, मतलब इट इज़ नॉट इम्पॉर्टेंट टू कीप 3 बिफोर एनीथिंग. ऐसा कुछ ज़रूरी नहीं कि 3 के सामने कोई x है और x के पीछे मुझे रखना है. देयर इज़ नो सच x. सो आई कैन से या लेट अस प्लेस दिस 3. So, अभी तक मैंने क्या किया, मैंने 5 प्लेस किया और फिर मैंने 3 प्लेस किया. सामने से देखिए ऐसे करके कि मैं 5 लास्ट में करना चाहता हूँ, क्योंकि 5 किसी के पहले नहीं रखना है, 3 किसी के पहले नहीं रखना है, तो मैंने 3 रख दिया. फिर अब मैं कहूँगा देखिए मैं सिंपल DFS कर रहा हूँ. कैसे? मैंने इससे चालू किया, फिर मैं इधर गया, फिर मैं इधर गया, फिर मैं इधर गया, अब फिर मैं वापस आ रहा हूँ, फिर मैं 1 में आया. अब मैं देख रहा हूँ इसके बाद और कोई नहीं है, जो भी थे मैंने उनको रख दिया है. So if I've allocated the person who was already present in front of me, what can I say? I can now place myself. So ये बंदा खुद को रख पाएगा इधर, ये बंदा खुद को इधर रख पाएगा in 1. Make sense? Because मैंने DFS कर लिया इधर से, और जो भी मेरे चिल्ड्रन है या मेरे नीचे है उन सबको ही मैंने किसी न किसी तरीके से पोजीशन कर दिया है. So I can now place myself before them, कि हाँ मुझे इन सबसे पहले आना है. Now let us move backwards, कि अब मैं 2 में आया. 2 को रखने से पहले मैं देखूंगा इसके और चिल्ड्रन क्या है. मैंने देख लिया कि इसका चिल्ड्रन है 4. तो मैंने कहा कि 4 के लिए अब चिल्ड्रन क्या बचा है. मैं देखा कि अच्छा यहाँ से तुम विजिट कर चुके हो. दिस इज विजिटेड, ये विजिटेड है मतलब इसके चिल्ड्रन भी विजिटेड होंगे। डीएफएस ऐसे ही काम करता है कि ये विजिटेड होके अगर लौट आता है, इसका मतलब उसका सारे चिल्ड्रन विजिटेड हो गया। सो वी कैन से ठीक है, इसका मतलब इसका काम खत्म हो गया। अब मेरे पास और कोई चिल्ड्रन नहीं बचा, मतलब जो भी मेरे चिल्ड्रन थे या लाइक मेरे नीचे थे, आई हैड टू एंश्योर कि वो सब मेरे सामने रहेंगे फाइनल लिस्ट में। तो मैंने ऑलरेडी सामने रख चुका है, तो अब मैं सिंपली इसको लेके 4 को लेके इधर रख दूंगा। मैं कहूँगा कि हाँ, इट इज़ टोटली इन ऑर्डर। आई विल कम बैक एंड 2 विल देन कॉल 6 इधर आके बताएगा ठीक है, आई एम फाइन ओवर हियर, एंड देन वी विल हैव 2 ओवर हियर। मेक सेंस? वी कैन हैव दिस 2 दैट ओके मेरे सारे चिल्ड्रन मेरे सामने बैठ चुके हैं, मैं बैठ जाता हूँ। किस केस में ये चीज़ होल्ड नहीं करेगा? ये आइडिया तो इंट्यूटिव लग रहा है कि मैं क्या बोल रहा हूँ कि बच्चों की तरफ जाओ, जब देखोगे कि तुम एकदम डेड एंड पर हो, कुछ नहीं है, तो उसको मार्क कर दो एज अ लास्ट एलिमेंट, फिर पीछे आते रहो। जब तुम पीछे आओगे तब तुम देखोगे तुम्हारे सामने जो है वो तुमने ले लिया है, तो इसको तुम डिनोट करोगे एज द second last element or third last element, like this. As you come backwards, you will say that you have to keep that in the list backwards. Okay? तो लास्ट में जब आप रूट तक पहुंचोगे तब कह पाओगे कि हाँ, दिस कैन बी प्लेस्ड एट द बिगिनिंग। सो ओवर हियर भी आप तरीके से अलग अलग तरीके से डीएफएस कर सकते हैं। सपोज वी स्टार्ट फ्रॉम दिस नोट, वी स्टार्ट दिस डीएफएस, तो हम क्या कहेंगे कि 1 के लिए पहले हम देख लेते क्या क्या चिल्ड्रन है। सो हमने देख लिया इधर 5 है, तो हमने 5 बिठा दिया क्योंकि 5 के लिए और कोई चिल्ड्रन नहीं है। फिर हमने बोला कि इसके दूसरे क्या चिल्ड्रन होंगे, 3 है, तो 3 को देख लेते हैं, 3 के भी कोई चाइल्ड नहीं है तो 3 को बिठा देते हैं। फिर हम 2 में आते हैं, 2 के लिए हम देखेंगे ऑलरेडी 3 प्रिंटेड है, तो इसको देखना नहीं है। 2 के लिए 4 है, बट 4 के लिए 5 है, तो हम 5 में देखेंगे कि 5 ऑलरेडी प्रिंटेड है, तो इसका मतलब यहाँ से अगर और कुछ भी है तो वो ऑलरेडी हुआ रहेगा। देन वी कैन से दैट ओके 4 की अब बारी, क्योंकि इसका और कोई चाइल्ड नहीं है तो 4 को ले लेते हैं। फिर हम क्या बोलेंगे, पीछे आते हैं, 2 के लिए तो 3 है जो कि ऑलरेडी टेकन है, तो 2 ही बस बचा, वी कैन टेक 2। अच्छा, 1 इधर मैं बिठाना शायद भूल गया, तो मैं 5 से जब लौटा था और 3 से जब लौटा था, 3 के बाद मैं इधर 1 ले सकता हूँ, राइट? मैंने 5 और 3 ले लिया तो मैं 1 ले सकता हूँ इधर आराम से, राइट? मैं कह सकता कि ठीक है अब मैं इधर से चालू करूँगा, इट इज़ अ डिफरेंट काइंड ऑफ सॉर्टिंग। मैं इधर से चालू करूँगा तो मैं क्या कहूँगा, 2 के लिए अंदर तक घुस जाओ, तो देखो इधर सपोज हम इस तरफ गए तो हम क्या कहेंगे कि 3 विल बी द लास्ट एलिमेंट, इसका और कोई चिल्ड्रन नहीं है। वी कैन से दैट ओके 3 कैन बी द लास्ट एलिमेंट। Then we can say let's come back and what can be other children? Okay, this one. 4 के लिए children अपने पास है, so 5 है, तो हम 5 को रखेंगे। फिर पीछे आएंगे तो 4 अपना रख सकते हैं, 4 को हम रख लेंगे। फिर पीछे आएंगे we have this 2, so हम कह सकते हैं we can say that okay 2 can be my next element because 2 has seen all its children and all its children are located in front of it. Okay, फिर we can say go to 1. For 1 you can see 5 and 3 both are covered, so you can just place 1 over here. This is also a correct topological sorting. Makes sense? Does it make sense, guys? Makes sense, right? सो अभी तक हमने कैसे सॉल्व करेंगे ये सॉर्ट ऑफ मतलब बस एल्गोरिथमिक तरीके से डिस्कस किया, नॉट कि हमारा फ्लो ऑफ कंट्रोल कैसा होगा, बट हमने सॉर्ट ऑफ ऐसे डिस्कस किया कि पीछे से कैसे रखेंगे। पीछे से हमने डिस्कस कर लिया कि इस तरीके से रखेंगे। सो इज इट फाइन अप टू नाउ? ओके, सो नाउ व्हाट कैन वी से? we are only left with the coding, so let us proceed over there. What is the data structure that we can use? हमें तो फॉरवर्ड तरीके से प्रिंट करना है, तो किसी तरीके से हमें स्टोर करना है। What is the perfect data structure that we can use for this task? हम कुछ ऐसा कह सकते हैं कि हम लोग इस तरफ से ऐसे स्टोर करते जाएंगे, तो हम लोग इस तरीके से अगर प्रिंट करेंगे तो हमारा प्रिंट हो जाएगा। सो इट इज समथिंग लाइक जो भी हम लास्ट में पुश करेंगे उसको हमें फर्स्ट में डिस्प्ले करना है। Whichever node we are going to display at the end, we are going to display, like we should display that at the first, whichever node we are going to push at the end. So this actually shows the property of a stack. From here we actually get the notion of a stack. और stack के कोई भी question आप vector से भी कर सकते हो, but it totally depends on you. But this is a question which we can say कि एक बार करके सारे push करते जाएंगे, फिर डायरेक्ट हमें बस पॉप करना है हमारे टॉप से लेकर लास्ट तक, बिकॉज जो भी एलिमेंट अपने पूरा एकदम बाप बन के बैठा हुआ है, whichever is seated at the root, we can say that will be pushed at the very end at the very end of the process. So we can pop that at the beginning and declare that that is the first element to be covered, so that all its children can be covered after this. Okay, now for which kind of graph this is not solvable, like this process won't work? For which kind of graph this process won't work? तो हम क्या बोल रहे हैं कि हम स्टैक में मेंटेन करते जाएंगे जब तक हमें चिल्ड्रन मिलेगा. So long as we get children, we will keep on adding to the stack. So what can we say from that? We can say something like this, that if there is suppose a directed cycle, then what can we say? Suppose we start from A. If we start from A, then what can we say? Ki after A we can visit B, then we'll visit C. From there we'll visit A, from there B, from there C, from there A, and so on. It will keep on rotating, right? So there is no topological ordering. Now if I say that okay, A was visited, I'll mark A as visited, then it is fine. We can say that okay, ABC can be written, like the algorithm can bring out ABC, but there is no defined topological ordering. If they all fall in such a circle, that means C has to come before A and A has to come before B, which has to come before C. So there is no perfect ordering. So this is not defined for a cycle. This is not defined for a directed cycle. Make sense? और डायरेक्टेड साइकिल कैसे निकालना है ग्राफ में, वो मैंने पिछले वीडियो में कवर किया था, which started at 6 o'clock. So you can see that video. That will again be quite an interesting exercise. Okay. So that's it. Now, is it important always to start from the root? इसको देखिए और बताइए क्या ये important है कि हमेशा 2 या 1 से हमें स्टार्ट करना चाहिए जिसके अंदर कोई इनकमिंग एज नहीं आ रहा है. हमें पता है देयर विल बी एटलीस्ट वन नोड विच डज नॉट हैव एन इनकमिंग एज. वी नो दिस. हाउ डू वी नो दिस? क्योंकि अगर एवरीवन हैज़ एन इनकमिंग एज, फिर हमेशा ये साइकिल लाइक किसी न किसी तरीके से हमें मिल जाएगा. सो एक तो ज़रूर होगा जिसके अंदर इनकमिंग एज नहीं होगा, विच वी कैन से कि वरना क्या हो जाएगा अगर इनकमिंग एज रहेगा. वी कैन नॉट. ओके, सो इफ़ यू हैव एन इनकमिंग एज, सपोज दिस एक्स, इफ यू हैव एन इनकमिंग एज, व्हाट कैन वी से कि वी कैन नॉट प्लेस दिस एट द बिगिनिंग, राइट? इट कैन नॉट बी एट द बिगिनिंग, right? So there has to be some node which will not have an incoming edge, and that node can form actually our first node. So here we can see one is our first node, here 2 is our first node, both are valid. But do we really need to find out a valid node from where we can start? Visited use क्यों नहीं कर सकते? Okay, where? Okay, over here I think, right? For a directed cycle we can use visited, but the thing is that okay, for directed cycle we can use visited, but there is no topological order defined for it. Suppose I say that ABC, this is a topological ordering. Does it make sense that A should come before C, whereas I see that C should come before A according to this particular link? So if there's a directed cycle, that means there is no answer possible. Okay, it is not about we cannot implement it, we cannot find it, but there is no answer possible, right? That is the only thing. Now the thing is it always important to start from the root? हमेशा इस ग्राफ में is it always important to start from either 2 or 1? Can't we start from 4? Can't we start from 3? Can't we start from 5? What do you think? So actually we can start from any node. You can start from, like, this process actually does not depend on the ordering. Why? Because suppose you start at node 4. Okay, what do you say? I'm at node 4, so first check all my whatever are my subordinates. We are going to take a subordinate which is 5. Then we are going to take 4. So we have got 4 over here. Yeah. Then we can take like from any node. Now we can start from maybe 1. We are leaving 2. So see, there is no damage due to that. From 1 I see that 5 is visited, now 3 is left. So for 3 I have said okay, visit 3. From 3 nothing else is there, that is why visit 3. Then visit 1, and then when I come to 2, I say okay, you can place 2. So see, you can start actually from any node. Why is that? Because whatever node you choose, you ensure that after choosing the node, you are covering everything within the subtree. Everything over here is first coming to the end of the list. Then you are saying you are going to bring this x. And if there are some nodes from where you can reach x, if there are some nodes which should come before x, you are going to visit that later. So if you are visiting that later, you are going to place it earlier. You are going to place something over here. Okay, so it does not matter which place you are starting from, which node you are starting from. You can start this particular algorithm from any node and it will always give you the correct answer. Make sense? So that's it. This is topological sorting, and if you are not aware of the algorithm, often in the face of interviews, this may be a big surprise to you. So in my interview at Google, I have faced a similar question on topological sorting, and I had to implement from scratch because I did not practice that much. But yeah, I was able to come up with the answer, and that question had more than topological sorting, much more than topological sorting, and eventually I was able to solve it, of course, because I cracked it. So this is definitely a very important topic for your interviews, and if you have 2-3 easy questions, this can form one of your medium hard questions. So you should stay prepared with these implementations. Okay, so cool. I think we can move toward implementation because we are done with the concept. What was the question? I don't exactly remember. It has been a long time actually. There was again some dependency, and there was maybe some matrix kind of a thing. I don't exactly remember. I don't remember the question. And I have given so many interviews in this COVID period that it is not possible to remember all the questions. But yeah, I think in the Google interviews only I had been asked a total of how many? 8 to 10 questions. So it was not possible to remember everything. Okay. But yeah, definitely in this particular interview, this was one such question that if you answer this, you have done the interview. If you couldn't answer this, then it depends on the interviewer. Okay. So done means you need to also correctly implement it, not just tell him the concept. Yeah, hi Omkar, hi everyone. So let us proceed to the coding. So we are going to target something. We are going to mention something like touch. I can mention outside this, maybe in interview questions part, interview problems. Let us have it there. Yeah. I'll copy something like combinations .cpp. Yeah, I'll copy this to topological sorting, topological sort.cpp. Yeah. So let me remove all these things. Okay, int main, and let us take something like lln, that is the number of vertices, and maybe m. Okay, so we will enter the number of vertices, and then we will enter m, and then we will say, let us for a moment, let us check whether there is some existing question. CAS let us see if there is some existing question. I think course schedule, this might be one. A and B, A has to be completed. Yeah, so we have got a question. Okay, I remembered that I had seen something like this. So we'll basically solve this question. We'll basically enter over here. So we have A and M, and we have all these edges. So A and B can be, and it is a directed thing. A has to be completed before B. So let us see how we can do it, and we have to print in that order. So let us see for LL I equals 0, I less than M, I plus plus, and we will store something like adjacent. Vector LL. So this is a kind of 2D array which I'm maintaining for my adjacency list. This is not adjacency matrix, this is adjacency list. I will say adj n plus 1 comma vector LL. In this matrix, what I'll be storing is that from a particular node, which are the nodes I can reach. That is what I'll be storing. So I'll be entering first of all the vertices LAB, or so when you'll be solving it in your interviews, please make sure that you use correct variable names. Over here I'm using simple variable names just to make it faster. Please use proper variable names, vertex 1, vertex 2, whatever you think, okay? Because that actually matters. So we have taken this, and from here what can we say? ADJ of A dot pushback B, something like this. Now what can we say? We can say that let us do DFS. So we will initialize some stack where we'll store the values, vertices maybe V, and then we will run DFS. DFS we will basically cur. Okay, so I think we can copy this to that particular folder, or I'll do this later on. Let me complete this DFS. From 1 I'll be doing, or let us do it from all these nodes. For LL I equals to 1, I less than equal to n I plus plus. And what else shall we do? We'll have some vector of visited, as we usually have in any DFS question. LL visited n plus 1, and we'll have false, means they have not been visited. So I think we can have 0 over here. Yeah, we can have 0. Now we will see if it has not been visited. If it has not been visited viz of I, then do DFS over there. Okay, do DFS at node I, and where should we go? We will take that this is list. We will take the visited one and nothing else. Now we can proceed over here, and we can say ll void DFS and these things. What are the things? We have to take the current index. We have to take this particular vector by reference. So you have by reference over here, and you need to take this particular vector which is visited. Take this, and okay, the stack is important. So do take the stack also. I hope the stack is also passed by reference. So I'll be passing that also by reference. Stack V, we can say. Okay, so if I see that it is visited, I won't be visiting it in the first place. Otherwise I'll say okay, viz of car equals to 1. We have visited it. Now what are we going to say? That visit all its children. Whatever you find inside ADJ car, visit all of them. If car is like if Y is visited, it can happen, right? That Y itself is visited. We had seen in this particular example that from here, from 4 we have visited 5, hence when we visited it from 1 we should not visit it again. So this is visited. So we are not going to visit it multiple times. So if it is visited, then continue. Else we will say that do a DFS using Y and ADJ and viz and V. Okay. And what shall we say? That when the DFS is complete, that means you have visited your children. Now push it. V dot insert this particular vertex which is car. Make sense? So here you have the total stack in front of. Now what can you say? You come over here and you say while stack dot size is greater than 0, then basically cout v dot, I think it's top, and then you say v dot pop. I'm not sure if pop returns anything. In Java it does return the integer, but I think in C++ it does not return any integer. So I did it separately, and then cout endl. Let us have this so that it is legible. Space. Okay. Now I think in the question, okay, so we have to print whether it is possible or impossible. Now impossible means that there is a directed cycle. Okay. So if there is a directed cycle, then it is really a problem. So I think we can use one of our solutions. Or if you do you want me to code that how to detect a directed cycle in a graph? Do you want me to code that? Let me know. There's a slight lag. So do you want me to code that? How to find a directed cycle in a graph? Because if you find a directed cycle, then it is not possible. Else it is always possible. We have some time left, so do you want me to code that, guys? Okay, so you can do it yourself, right? Okay. So I think I have done it previously somewhere. I'll explain it slightly so that it does not remain unknown to you. Which is the question? Cycle finding 2, is it? Yeah, I think so. So this is a DFS that we are doing. Yeah, no need. Right. So fine. So for now we can maybe end with this. Let us say we run this, assuming that it is always possible in topological sort. Let us run this topological sort, not CPP. I think, yeah, we have to check cycle bus, right? That is what I said. So instead of checking, just I am going to run for this particular test case because I know it is possible for this test case. I'm going to run for this. DFS, no matching call because I think I did not pass the stack. So it is a V. Okay, and over here I think you place 2 brackets. I'm a Java coder, so please understand these things. V dot insert. What is V? This is stack, right? Okay, V dot push. Where did I write insert? Okay, this is V dot push. Yeah. Now what can we say? Dot slash out 45312. This is 34152, but you can see 45312 is also fine. 4 should come before 5, 5 should come before 3, 45312. 3 should come before 1, 1 should come before 2. So you can see this is also correct. Makes sense? Okay, I'm sorry. This 5, 3 is not the input. This is not an edge. These are the edges. So we can say that, okay, this will work. So I can't submit it right now. Maybe I can add that part, which is cycle finding. So over here we have to check, does cycle exist? Something like that. Is cycle or does cycle exist? Does cycle exist? And I can maybe pass it. What are the things I need to pass? The adjacency list. I need to pass number of vertices. And what else? That's it. The rest it will take care of. So I will get some value from here. Boolean flag. So if I find Boolean flag, or you can mention it as is cycle. So if you find that there is like the flag is true, then you are going to say if flag, then basically cout impossible /n, that is endl. And what can we say? We can return it from here, return 0. Else we are going to do this. Does cycle exist? It will have its own thing. Does, okay, it will have a bool. Bool, does cycle exist? So you have n and adj. So lln and vector ll ampersand adj. Over here you can use this, something like this. So let's copy the important part, color distance. Is this the algorithm cycle finding? No, this is a different question, I think. Flight routes, maybe this one. No. I score round trip to, maybe this one. Yeah, this one. Okay, so we can use this code. Flag equals to 0. We can start from this, and then over here we'll basically be returning. We just have to return this. If flag, yeah, there's a small code over here, and then we have to copy the function. So what I'm saying is, let us keep a boolean variable, bool flag, or maybe we can say bool is cycle equal. We have is cycle equals 0. Is cycle equals 0. Then we are going to replace this by is cycle, and that's it. Now what we can say is, we'll be calling something instead of DFS. Let us say find directed cycle, or DFS1, maybe something like this, DFS1. So when we'll do DFS1, let us do this one. Let us copy this part, void DFS1. There is one part which is not needed. We don't need the path. We are not interested in the path. The cycle.exist, we don't need this prev thing. We don't need this prev thing. We can go something like this, and here you go. So this is going to be DFS1. From here also it is going to be DFS1. Okay, and flag. I think we had a flag over here. So wherever you're having flag, uh, instead of that, change it to is cycle. That's it. And we see that it's the same flag that we are using outside. We can also exchange it. So we can say instead of is cycle equals to y. We can just say is cycle is equal to 1. And we don't need this prev. So we won't keep this. We won't keep this prev either. The previous node. This is not important. This is not important. Else is cycle is equal to 1. I can just return from here. Okay, no, the outer one is also important. Okay, so that's it. I think this previous ones are just not needed. Except this is the same thing. So we are doing all the essential things, and over here we will return is cycle. Make sense? We can also keep it global. That is also fine. But okay, let us have the answer here, and then we will do something like this. So right, let us check now. Okay, bool does exist no known conversion from vector vector long long to vector long long. So again, the typo. I think I wrote vector. Where did I write? Line 39. 39. Okay, vector vector. Vector vector ll. And now we can say that's it. Void DFS1 requires 3 arguments. I have given 4. Where did I give 4 DFS1? Maybe when I'm calling it, I should remove this previous. That's it. Now it will compile correctly. I just need, sorry. I'm sorry. I copied the entire program. Copy. Let us come back here. Yeah, 45312. So we have 45312, and now we can maybe create a cycle and see how it goes. Suppose there are 5 nodes and there are 6 edges, and suppose we have something like this. So 1 2 2 3 2 4 5 6. Yeah, sorry, 6 does not exist. So 5 6, we have 1 2 2 3 2 4 3 suppose 4 1, and then we have something like 4 5 and 3 5 maybe. Okay, so it is impossible. It is printing it. So we can maybe try submitting it. Main, sorry, not main. What is the okay, it's in a different folder. Computer programming lectures, interview problems, right? Interview problems, and we have for topological sort. So let us try submitting it. Yeah, that's it. So you can see this is passing all the test cases. So now if you have any questions in regard to this problem or in regard to anything else, you can ask. I'll move this topological sort to CSES graphs. What is the name of the question? Course schedule. Course schedule. And I'll update with this particular name in the GitHub so that you can find the code. Course schedule.cpp. Okay, so now it is deleted, and in CSES graphs we'll get it. So any questions regarding my interviews or anything else? Or else we'll finish soon. In regard to this problem or in regard to anything else, have you got anything to ask? Which thing? What do you want to ask? Any interview experience? Okay. CSES graphs, wait. And now I'll just check if I'm able to run it. Over here, course schedule. Yeah. And then let me just copy it. Problem approaching. Okay. So first of all, that's good. So this will also run. So first of all, in interview, since we have some time, we have around 10 to 15 minutes. According to the schedule, I was expecting to keep 1 hour class, but anyway, I will cover it. I'll finish it in 4 or 5 minutes. Uh, in the interviews, first of all, from freshers, since it is known that the freshers don't have industry experience to that level, there are only a few things which are expected. The first thing is they know all the coding fundamentals. Why this is done? Because it is known that it is common across all colleges, across all students. They are not fixing like in certain maybe web development, you have certain people following a certain tech stack, others don't follow that. In machine learning, we have got varieties. So there is significantly a difference from like them. For EXP means, for EPX means, okay, 2 year experience definitely. What counts more is the interviews. The interviews become very important. So I'll mention that. So there are usually like these steps. First, you have a coding round. Okay. First, you have a coding round, which is most important for freshers. So for freshers, usually for the selection among of candidates, coding round actually helps in shortlisting. But this is less important. This becomes a bit less important for experienced guys, because over there you have a lesser pool. If they have experience, then you require a lesser pool. You can directly focus on the interviews. For them, the interview becomes more important. Now, in interviews for people who are 2 year, 3 year experienced, there are two things which are important. One is the usual coding interviews, DS algo interviews, which are almost the only interviews for freshers, and you have the system design. So I won't be touching on system design much because I am myself not very experienced in that. I won't be touching on this. But in terms of DS algo, I can tell you what exactly are expected. So in interviews, when some question is asked to you, it is actually like the interviewer wants to know how you are approaching the problem and how you are solving it. So no interviewer expects that you should know the answer to this question and you should throw that on his face. The objective of the interview is to understand whether you know the sufficient amount of coding to crack a certain problem. If you know the problem beforehand and you express it in that manner, then you are not fulfilling the objective. So for these interviews, even for experienced people, there are only few things which I find important. One is you should have some experience, like some habit of coding, maybe you can call that. So some problem solving, you can say. So the way you approach a problem, this lies important. Then the appropriate knowledge of data structures. So you know when to apply which data structure. So DS and algorithms, they are important. When I say problem solving, it is about when a question is given to you, you may know all the algorithms, you know all the data structures. You may tell me I know stack, heap, queue, and I say okay, you surely know it. You know how to write down a stack, you know how to perform the operations. But can you solve this particular problem using your knowledge? So that is all that is always a different and a very important sphere of interviews. After that, one important thing is your attitude. And this attitude is not about the only way how you're addressing this interviewer or how you're speaking out or how polite you are. Not only these things. This attitude is how you're explaining the solution to the interviewer. And everybody expects that you can explain the solution to a person such that even if the person does not know anything, from your explanation he can understand that. Because see, in a company, since you are experienced, you might understand that in a company, when you are doing like some operation in some good companies, basically when you're working on some part, usually the task is modularized. You have to work on something and you have to explain that in a very short time to the next person who is going to work on top of it. So this particular task you need to be so good at it that when you explain it to the next person, it should become very easy for him. So every company looks for such people who make their processes and every procedure easy. Okay, basically keeping whom, it may not be like he will solve every problem on earth, but whatever he'll be solving, he will create a very good experience and ambience inside the company. So that is another thing, that whenever you are sitting in an interview, the employee does not know you, and it is not possible to know a person in 30 minutes. But what the employee will depend on is what he sees in front of him. What he wants is, after 1 year, I want this person, when he will work with me, he should be very lively, he should be very active, he should always, like, he should not do everything within his mind, then I cannot understand what he's coding. Okay, and then if he makes a mistake, then I cannot rectify it. If he leaves the company after making a mistake, then we are done for. So these are certain things which plays in the interviewer's mind and the recruiter's mind. When the recruiter asks an interviewer to interview based on these aspects, these are certain aspects that always play in their minds, that okay, this person should be very congenial in interactions. Whatever he's thinking, whether he's thinking right or he's thinking wrong, he should be very, not only just sporting in it, he should always have the ability of expressing. Because people make mistakes. If somebody does not make mistake, that means he did not get any challenging task where he can make a mistake. So everyone makes mistake, and basically somewhere or the other, a person understands that okay, this is either difficult, this is either easy or something like that. When there is a communication, tasks become faster, and nobody understands this more better than people who have worked in a company. When you are a fresher or you are slightly inexperienced, when you are working for such a role, what the interviewer wants is that this person, I don't know how much experienced he is, but when he comes into the company, he should create such an environment that our procedures become easy. We can depend on him not just for solving everything in one night, but rather making the entire environment easy. We have a steady flow. The flow may not be always like Usain Bolt or our expresses, our bullet trains, but it has to be something like it should be promising. If he cannot do, he should be able enough to come in front and explain what exactly problem he is facing and how we can perhaps take the steps to rectify our problem. So these are certain things which are important. Now coming into the granular details. Arjun, I am not accustomed to this kind of behavior. If you know me, and if you ever get to know me, and if we ever get to know each other, then it is good that you don't extend this kind of behavior. There is some experience with which we come forward, and it is only you who can be benefited from this. So from my experience and from this narration, I'm not going to gain anything. Yes, I'm going to get some incentives for this time I'm spending with you, and however it is, however bad it is, I'm going to get the same thing. But the important thing for you is you understand what is effective for you. If you are not interested, just go wherever you are interested. Nobody is stopping you, and it is a practical advice. I have also run from classrooms where I haven't enjoyed. The topic is over. I'm sorry if I disappointed you by going through these things. The topic is over, so you can watch the recordings. But this is because I pasted it up because this is found to be important. In some sessions, I can't keep something just on interviews. I don't like mentioning that. I don't like prototyping for you guys. But if it comes to simple, 15 minutes, 5 minutes discussion, I like to spend that time. So whatever it is, anyway, if I understood it wrong, that's okay. But please control your tone as well. It may happen, yeah. Anyway, so that's it. For improving your problem approaches, you can work in competitive programming, and you can follow programmers like us. You can follow us on programming websites like CodeChef and CodeForces. We interact with people there also, and you can see our submissions and everything. And what else? Where were I? Okay. So usually the expectation from interviews is that not that you should be a competitive programmer. What is a competitive programmer? One who not only is able to solve problems, but one who likes to compete with others in solving problems. So if you can establish that you are a competitive programmer, it becomes a much more strong point in your interview. Why? Because, can you answer just one question? Yeah, sure. Sure, Arjun, you can ask whatever question you have. But what I was mentioning is, if you can establish yourself that I'm a competitive programmer, the interviewer understands that you are not just doing something just for the sake of doing it. Just a second. Yeah. But you rather enjoy the thing. You enjoy coding, and you like participating with others, and you participate in healthy competitions. This is a very important thing, and if you can actually convey to the interviewer that I think like a competitive programmer, that actually means a lot. So while competitive programming is not at all necessary, it is actually very good in improving your aptitude, your approaches. When you see a problem, you should first of all think what should be my first step, whether it should be DP or bitmask or something else, right? So that particular approach comes through this practice of visiting problems and brainstorming about it. Not only known problems can guide you in it. Suppose you have to form a total system where we have to deal with some COVID issue, maybe where you have to deal with apparatus, you have to form some scalable system and whatever else. So over there, everything what matters is whether you are interested in the task, whether you can think widely on all the possibilities. This is what interviews basically look for. I'll come to the questions. I'm working at a product based company and they are having their own technologies and tools. Will I get benefited? Definitely. The thing is that these all technologies have a common source. So through all these technologies, the more deeper you go, the better understanding you develop. And when you know all these steps, it actually enables you to understand the entire workflow. If you can form a holistic understanding around everything, then the moment you switch to a new tech stack, it will become very easy for you to understand the similarities and differences. You should not mug things or you should not memorize things like these are the steps that I need to execute to run this database model or something like that. The thing is that if you understand basically how it is working, how these NoSQL SQL things differ, how this scalability is affecting this particular project, and how in the tech stack I'm maintaining it, you can stretch this idea to other tech stacks as well. So it is definitely like this is emphasized always that whenever you're working at something, like stick to it and try to get as much as you can from it. Try to gain holistically from it. When I switch to other companies, because for second company anyway, I will be fresher in knowing open source. Definitely, you will be a fresher, you will be a newcomer for the tech stack. But what the company will look for is that wherever you have worked, how active you were. If you can establish, I worked over here, it may be that the interviewer has no idea about the tech stack, but from your explanations, when he gets the understanding that you have done sufficiently good work in that, you have a good understanding of that, in very easy language, you can describe what are its differences from other things, which maybe one or two other companies might be using. It will have a very good point in the interviews. Technologies will come and go, definitely. Today, what we are using, all this TensorFlow and whatever else, Keras and whatever we are using, 2-3 years later, maybe they will not be used. But the people who know how to use them, who know what are the parameters that we use them, that we use in them, that we configure in them, that will help them, do mellifluously in the next technologies as well. Why not? Actually, I'm trying hard for Switch, but not able to crack and do not know the reason. The thing is like. Maybe after 6 months I can help you better because I'll be more adapted to those workflows. 6 months or 8 months, you can connect to me on LinkedIn. You might find like I usually remain active at least till now. So the thing is, you need to do some kind of coding so that those data structures and algorithms part you can completely crack. And if I talk about the people who have switched from other companies to Amazon and Google, even they, I can see that I don't know what is their prowess in web development and everything, but in coding they all have stressed. I can say that this time I'm moving into Google. There are many seniors of mine who are moving into Google. Now they are seniors like from 1 or 2 months I know them. We interacted in terms of computer programming, and then it turned out that we are all entering Google together. So the thing is that in these years they have focused largely on computer programming, and not on computer programming, rather on these problem solving things, data structures and algorithms. So if you stress on this, I think like yes, if you get referral, it will definitely make your task easier. You can definitely look out for the roles because Google is hiring for all the roles you can find on the careers page. You can apply on them, and whatever you apply in, build sufficient profile, take 6 months, develop yourself sufficiently in that together with whatever you're doing in your offices, and that's it. Leave everything, like there is some factor of luck always there, but there is definitely a big portion of your fate which is connected with your endeavor, with your dedication and everything. So it is tough, I know, and how much tough it will be tomorrow, it depends on the market tomorrow. So we have to leave certain things for those things. I am learning how the software industry is working and know the workflows. Definitely, that's a good thing. That's definitely a good thing. So anyway, I'm sorry if I lost my temper in between. You can let me know through your comments and feedback how bad you felt, how good you felt, whatever, and which topics you want interviews in, because maybe for a few more days I'll be continuing, or I don't know that. So, and I have not yet opened my own YouTube channel, and in the near future I'm not going to open it. So through these channels only I'll be continuing for some duration. If you have any complex topics in your mind which you think it is hard to understand, you can refer to me. Okay. So I can take sessions on that. I've been taking sessions on segment trees. I've taken sessions on binary lifting and many such similar topics in at Unacademy. So anyway, uh, yeah, that's fine. So cool. I think at least there was something that you could get from this discussion, if not everything. I'll quickly tell you about the batches at Unacademy because I'm required to talk about that. Uh, so okay. Yeah, definitely. Like you should never feel that regarding whatever you're doing. Wherever you are, try to feel that okay, this is a platform and try to gain as much as you can from there. Don't disown that. That is the truth currently with you. Try to utilize as much as you have from the platform. So even if you're in college, it applies the same thing. 99.9% people don't utilize their colleges, the platform that they get in their colleges, the faculty members, the students, the peers, the excellent some people are excellent in certain things. They don't utilize it always. They feel shy to approach to people, but you can utilize this platform very useful, like very significantly. So this is what discriminates one student from another. They all start from the same level. Yeah, they start from sometimes from different levels, but two students who start from the same level, how they utilize their platform largely influence, like largely creates them. Okay. So that's it. I think let me cover these batches quickly. These are 4 batches which are currently being offered at Unacademy. Transpire is on CS fundamentals. Eklavya is on programming for beginners. These are 7.5 months. Brahmastra 3.0 is for off-campus and college placements. Mahayadha 2.0 is for advanced programming. They have all started on 20th July or 21st July. And through this, you get a structured learning path. If you take one subscription for a certain period, for that period, you can get unlimited access to all batches and courses. That's it. And you have this batch structure. You have Transpire, you have computer networks, and all these CS fundamentals you have in this particular course. Then in Eklavya 3.0, you start with the beginner level things. For the first 8 weeks, you do beginner level things. Then you do the intermediate level things, and then the advanced topics, square root decomposition, number theory. We covered this recently in one of our courses. You have RDP and you have graph algorithm with extensive problem solving. You have Brahmastra 3.0 where we cover only the interview related topics, maths and puzzles for interview preparation, sorting and searching, and all these things. You have string algorithms where you have basically all your KMP algorithm, Rabin Karp, Manager, all these things. You have advanced dynamic programming, you have graph algorithms, and then interview problems asked in FANG on top product companies. Mahayotha 2.0, you have this advanced dynamic programming. This is something that we have been covering recently. I have been taking this batch. We have done advanced dynamic programming. Before this, we did advanced combinatorics. Now we are working on segment trees. Then we'll be covering advanced concepts of graph theory, then mixed problem solving. These are some of your educators. You have some good profiles. You get live interactive classes, practice relevant problems, doubt support. And these are some of those profiles. Okay, so these are the pricings. 1 month 6,000, 12 months is quite discounted. You can see individually all of them. 3 months 16,000, 12 months 33,000. This is quite discounted. You can think about this. You can use my referral code, and for special classes, you can go to the site. Whatever you want to unlock, you can use my referral code to see them for free. You can see all the special classes for free using my code Saptarshi1729. And if you want to take a subscription, you will get additional 10% discount on top of this, again using the same code. So you can consider this. And these are again some campus placement IT like batches. You have Achiever batch and you have Hall of Fame batch. Achiever batch will help you prepare for TCS, Infosys, Wipro, and all these things. Hall of Fame batch will help you prepare for dream companies such as Deloitte, Ernst and Young, Samsung, and others. Okay. So that's it. So I think it is good for today. Try solving this question by yourself as well. Course schedule. You'll be able to learn these things. And yeah, that's fine. And okay. So take care. I'm again apologetic about losing my temper because anyway. So actually, some person in the past he told me that He is actually a bit dissatisfied with some behavior of some student. I actually like, I would like to plead to you that whenever you find some educator, he might not have profile like us, he may have a better profile than me, he may have a worse profile than me. Whenever you choose somebody, try to get as much as you can and try to reciprocate. If you don't like me, go to somebody else. But like whenever you come to somebody, try to just keep that atmosphere as smooth and as sound as possible. Okay, anyway, so don't take it otherwise. I think that's good enough. So take care and keep coding. And if you all do something good, I'll be very happy to know. Thank you. Bye.